Alrighty. For this one, the first step is to get the x by itself. So basically, we're going to first add 2/5 to both sides. Bam, that's gone. We have 2/3 x equals, 2 plus 2/5. We need to change 2 to have a 5 on the bottom. So I'm going to multiply that by 5 over 5. Is that okay? This is 2, this is 2/5. I need this to have a 5 on the bottom, so multiply by 5 over 5. So it looks like I have now 10/5 plus 2/5 over here. Because 5 over 5. Okay. So that would be 2/3 x equals, add the tops, 12/5. Now, how do we get rid of that 2/3? You divide by 2/3. Now, there will be a shortcut you'll see in a second, but if we simply divide by 2/3, what you'll realize when we do this will cancel, leaving you x. But when you divide, that means 12 over 5 divided by 2/3. What does that mean? You flip the second one, which means 12 over 5 times 3 over 2. Multiply straight across now. 36 over 10, which that can be reduced. What goes into both 36 and 10? 2. 18 over 5, and that is fine for an answer. Now, instead of doing this dividing by 2/3, do you understand when you divide by 2/3, really you multiply by the reciprocal? If you can get that in your brain, that whenever you divide by a fraction, you're really multiplying by the reciprocal, could I have just right off the bat multiplied here and here by 3 over 2, 3 over 2? Hopefully you get to the point that you can realize I just multiplied by 3 over 2, 3 over 2. The reciprocal of this, that's quicker. But if you can't, you just multiply by the fraction. With practice, you'll get better at it. All right. Now, number 5. What do we want to do to get rid of all the decimals? We multiply by something. Both sides, or I can just, if I'm multiplying both sides, can I just multiply the whole thing? And I'm going to multiply the whole thing by 10. When I multiply everything by 10, that becomes 72. That becomes 15x. That becomes negative 86. And this becomes 23x. You can multiply both sides by 10. And now your decimals are gone. A lot easier. Try the easiest way to do decimals. Again, if these decimals had like a hundredths place, you have to multiply. If any of them had a hundredths place, you have to multiply everything by 100 instead of 10. It's all depending on the decimal, the place values of the decimal. Now, solve when we get the x's to one side. Yes?
So even if just one of them had a hundredths?
If one of them had a hundredths place, the whole thing needs to be multiplied by hundreds in order to get rid of all your decimals.
Yeah.
If one of them had a hundredths place, you could do tens, and one of them would have a decimal. Deal with it later. Okay. So if we want to solve this one, I'm going to get the x's hopefully to this side. So I minus the 23x over. That's gone, leaving you negative 86. 72 comes down, and when you subtract these, you get minus 8x. The x's all on the left. So I need to move this positive 72 over. So I'm going to minus the 72. I hate big numbers like this. Gone. These two give you negative 158, it looks like. Getting some big numbers. Now, to get the 8 off the x, since it's multiplied, we have to divide it off. What's a negative divided by negative? Positive. Now, let's just reduce. What's an easy number that goes into both those? Since you just, I don't know for sure. Do you know for sure if 8 goes to the top one? No, let's just try 2. Is that okay? 2. We could divide that in half. First of all, that's 4. Divide this in half. That's going to be a 4. This is going to be a 74. No, wait. No, it's not a 4. 79. 75 would be 150. I think that's right. 79, I believe. Let's just try. 158 divided by 2. Is that okay? 2 goes into 15 7 times. Is that 79? Okay. And 9, 2, will 2 or 4 go into a 9, an odd number? No. So we're done. Now, that is a lot easier, I would think, by getting rid of the decimals. Makes life a lot easier.